Okay, so this is our word problem right here. So at Rocking Horse Ranch, admission is $45 to walk in, and trail rides cost $22.50 per hour. At Saddle Creek Ranch, admission is $30, and trail rides cost $35 per hour. Part A says to write a systems of equation to show the total cost, C, for a trail ride that lasts H hours. So I need two equations. That's what a system is, or a system is two or more equations, but in our case, just two. We need a Rocking Horse Ranch equation to represent the total cost. So the total cost at Rocking Horse Ranch is going to be $45 immediately plus $22.50 for every hour that you spend there. At Saddle Creek Ranch, the cost would be $30 initially and then $35 per hour. So in part B, when we need to solve, I'm going to set up this equation using substitution. Wherever I see C in the second equation, I'm going to replace it with 45 plus 22.5H. We need to move the smallest variable, so the 22.5H, over to the other side. And then we would subtract both sides by 30 to end up with 15 equals 12.5H. Divide by 12.5 to figure out the total number of hours where they're going to have the same exact cost will be 1.2 hours. So now we need to figure out how much the total cost will be at each place for 1.2 hours, but since we solved this for H already, it should be the same cost in each one. So I'm going to choose the first equation. And plug in 1.2. So we would do 22.5 times 1.2. Which is 27, which means the total cost would be $72. So what this means is at both places, after 1.2 hours, you will spend $72. You won't always be spending the same amount of money. This is the point where they would both cross their intersection point, essentially. Okay, the next one, we are trying to figure out if these ordered pairs are the solution to the inequality right here. We are not given a graph, so graphing would be really difficult. We would have to move everything to be in slope-intercept form, and then if we do that, we would have to divide by 5 and end up with a bunch of fractions. So what we could do instead, when you're not given a graph, is just plug in numbers and see if they make sense. It does take some time, but for example, for the first one, I would plug in 0, and then solve, so 0 minus 0 is less than or equal to 7. 0 is less than or equal to 7, so this does work. So that would be a solution. And now we repeat it for the rest of them. So y is 5 for the second one, and x is 3. So we're going to see if this works out. 5 times 5 is 25. 3 times 3 is 9. 16 is not less than or equal to 7, so that would not work out. And then we just keep repeating, plugging in x and y to see if they work. So the next one would be 5. Y is negative 5 in this case, and x is negative 2. So negative 25 plus 6. Negative 19 is less than or equal to 7, so that would be something that we could pick. So I'm just kind of rewriting the equation each time, ready to plug things in. This one, x is 1 and y is 2.5. This one would not work because 9.5 is not less than or equal to 7. And then finally, we'll check the last one. Okay, so negative 15 minus 15 would be negative 30, and that is less than or equal to 7, so that is another one that works. So this one does take a lot of effort. You could have graphed it, but you would have been starting at 7/5, which would be annoying on a graph. So your other option would be to literally like create a coordinate plane and count it all out. Okay, number 9 is a simple one. When is the boundary line of the graph of an inequality? When is the boundary line of the graph of an inequality in two variables part of the solution? When is it included? So that's what we were talking about the other day. If you have a less than sign, the boundary line is excluded. But if you had like a less than or a greater than or equal to, that's when you would include the solution. Okay, last question on this page. We need to write the inequality for the half plane. So we need to set up an inequality. I'm putting like a little box here because we have to figure out what the sign is. So we need to figure out the y-intercept first. That's the easiest, which would be -4. And then next would be the slope. So I could go up. Okay, so this graph is a little hard to see, especially on your paper because it is printed. As long as you're able to find a couple points, and I will make it a little bit bigger on the test. It does start at -4, and then the rise over 1 would be about 1/4, or like maybe 1/3, 1/5. All of these would be acceptable answers. And since it is shaded above the graph, you need to be having a greater than sign. Since it's a dashed line, we would just leave it as a greater than and exclude the boundary line.